Hello everybody and welcome to exercise 4 on page 69 of the workbook. And in this exercise, they're starting us off with a triple integral, and they're asking us to rewrite the integral by changing the order of integration. A problem like this is really good practice in seeing if you really understand how to find limits of integration, which is generally one of the more challenging tasks when we're doing triple integrals. Okay, so let's first notice that they showed us what the region of integration looks like. This picture is coming from the limits that we have over here. And you'll notice that this solid region in space basically has two surfaces involved. There's this plane, z equals 2 minus 2y, and there's this kind of curved surface, which is actually a parabolic cylinder, which is forming kind of the left side of this solid region. Okay, so in this video, we're just going to do half of this question. We're going to see if we can rewrite this integral in the dx, dy, dz order. Okay, so let's clear away a little clutter here and get started. Okay, so we'll call this part A. Dx, dy, dz order. Okay, so our ultimate answer to this is going to have the form then. Okay, I'm going to write these integrals and really space them out so that we've got room to write our limits. Okay, f of x, y, z. And we want to go in the dx, dy, dz order. Okay, so we're going to start with the innermost integral, as we always do. And we want to ask, what would the surfaces be, the bounding surfaces be in the x direction? Okay, well, notice where the x-axis is in our picture. Okay, it's sitting here, so that's the axis that's kind of coming straight out of the paper at us. So when you think x direction, what you want to think of is back and front. What's on the back side of our solid and what's on the front side of our solid? Okay, so back surface and front surface. That will tell us what our x limits are. All right, well, to answer that, when you look at this solid region E, what kind of a surface is on the back side of this region? If you think about it, it's this triangular shaped piece here. What is the x-coordinate? At every point on that back surface, it's equal to 0. That's a flat surface. And so our back surface is actually just the plane x equals 0. Okay? And so imagine kind of that you're on that back surface, and then you're going to move in the direction of the x-axis until you smack into the other side of the region. Okay, so you kind of move in this direction, and eventually you hit the edge of our region, and notice what surface we're on when we hit that other side of the region. The square root of x equals 2y is the surface that forms the front side of our region. Okay, but we're interested in x-coordinates. So if the square root of x is equal to 2y, we need to solve that equation for x, which we can do by just squaring both sides. Okay, so the front surface solved for x is going to look like x equals 4y squared. So, in a nutshell, we have just figured out what our x limits of integration are. On the back side, we're at x equals 0, and on the front side, we're at x equals 4y squared. Okay, so we are a third of the way there. We've got our x limits. Okay, and the next direction that we need to integrate is in the y direction. Okay, and since we're done with the x direction, we need to shine a light and think about the shadow. And since it's the x direction that we integrated in, the light that we shine is going to be along the x-axis. Okay, so imagine that you shine the light on this surface. What would the shadow of that surface look like on the yz plane? Okay, well, you can kind of see it here. The shadow is going to look like this triangular back portion, okay, of the surface. All right, and I'm going to draw that picture below. It's going to help us to figure out our remaining limits here. Okay, we've used the terminology projection picture. In this case, it would be a YZ projection. Okay, we just convinced ourselves that what we're going to see is a triangle. Okay, let's draw that triangle. All right, and if we look back at our integral, notice that the next direction we're integrating is in the y direction. That's going to be left to right. So visualizing this, we're going to be thinking about going in this direction, and what's going to be of interest to us is determining what y is equal to there and there. Okay, now I'm hoping that you can tell me what y is equal to on the left side. Okay, that's a curve that's given by y equals 0. In fact, let's kind of keep note of what we're doing here. So going in the y direction, we're going to have a left curve and a y curve. Okay, and we can see from the picture that the curve on the left-hand region, not really a curve at all, it's actually a line, y equals 0. What's more interesting is, what would y be over here on the right-hand side? Okay, well there, we need to know what the equation of this line is that we're looking at here. And we can get that by looking back at the picture. Notice that that line up here comes from the plane z equals 2 minus 2y. Okay, so that's our starting point. And so what it comes down to is, can we take that z equals 2 minus 2y and actually solve it for y? Okay, let's maybe do that as a little side calculation down here. Okay, sorry to be writing all over the page on you, but space is kind of limited here. So if we solve that for y, we can subtract 2 from both sides. Okay, and then divide both sides by negative 2. Okay, and what we wind up with is y equals z minus 2 over negative 2. Okay, I'm going to fill that in over here. Okay, so z minus 2 over negative 2 is the equation of our right-hand curve. Okay, and what we've just found then are the limits of integration for the y values. We've got a curve on the left, we've got a curve on the right, and those are going to be our limits. Almost there. Okay, so we've got our x and our y limits. The last direction that we need to integrate is in the z direction. And so let's see, we just got done integrating in the y direction, so we want to shine a light this time down the y-axis and ask, what would the shadow of this triangular region look like on the z-axis? Okay, well, you can kind of see the shadow here. Okay, and we can see pretty clearly that the z value down here is 0. What would the z value be up at the top? Okay, well, we can see from the picture up above that that z value is going to be 2. Okay, and that tells us then what our limits in the z direction are. Okay, so put it all together, and it looks like we've got an answer sitting right up here. There's our integral in the xyz order.